Hello, hello. We are back getting ready to discuss example 3. But before we do example 3, we have to talk about the wonderful, magnificent distance formula. The distance formula, just so you know, it's not going anywhere. This is something that you are going to use the entire year, so you have to memorize it. Maybe some of you already have it memorized, which is awesome. But yeah, you're just going to have to memorize this bad boy. So this is a flashcard. You got to go over it. Okay, go over, go over, go over. Flashcard for the distance formula. All right, so what it says for the distance formula is in a coordinate plane. Remember a coordinate plane, it has an x-axis and a y-axis and all the 4 quadrants and all those lovely things. What it says is whenever you have a point, right, and I mean not a point, but a line segment, and let's say you called this your, this was our x1, y1, and this was our x2, y2, that's a 2, and you want to find the distance between these two, you want to find the distance, whatever the distance of this line segment is, you would do it using the distance formula. The distance formula is the square root, okay, it needs to be highlighted. It just needs to be. It's going to be highlighted in green. Green is a great color. Okay. It's the square root of the difference of the values, right? So the difference of the x2 minus x1 and all of that is squared, plus the difference of the y values, y2 minus y1, and all of that is squared. And when you do all that, that's how you figure out what the distance is. Okay, so distance formula, distance formula, distance formula. I'm going to go ahead and just put a circle around it. This is to just show you how important this is for you to do. It's going to get a star too, a star. And you know what? What the heck? We're going to highlight the star in yellow. And we will see if it stays pink and yellow or if the pink bleeds into the yellow and it turns orange. What happens? You know, like a little yellow with a little orange around there. What about over here? Maybe the ink is dried longer. Nope, still the same thing. Still the same thing. But, you know, just to let you know, the distance formula is super important. Memorize it. Go for a walk. Say it over to yourself in your head until you have that sucker internalized. It's not going anywhere. It's going to come back all the time in a variety of different chapters. So I'm just trying to let you know. It will make your life easier, I promise, just to internalize that bad boy. So let's go ahead and look at example 3. Example 3, we're going to use the distance formula to find F, G, and J, K. So here's F, G, and here's J, K. And then what we're going to do is we're going to determine if line segment FG is congruent to line segment JK. So notice the difference in the symbols here. You see how FG doesn't have a line segment, but it does here? So it wants us to find what the actual value is. So we're going to be ending up with something like FG. We're going to end up with something like FG equals a number, right? Like 2. So whenever you have that, you don't put that line segment on there. And we're going to find JK is equal to, I don't know, maybe it's equal to 3. I don't know what it is. I'm just making it up, right? So the fact is you're putting those line segments, you're giving a value, like an actual number. And so use equals and you don't put the little line segment thing. But if that wasn't 3 and it was actually equal to 2, then we could say, hey, these two things are the same thing. We could say FG is equal to JK. Therefore, they are both congruent, and then that's when we put in the fancy little line segment on top, and we'd use the congruent symbol. So whenever you're using that congruent symbol, you use the symbolic form of a line segment. So what you do, and this right here, when you go from here to here, this is actually going to be a what is it? It's the definition of congruent segments. So it's a definition. It's a definition. I was trying to think, is it a postulate? Is it a theorem? Is it a corollary? This is a definition, but you haven't learned about it yet. But this right here, this is when you go from here to here, or if you have this and then you go from there, it's just going to be, it's called the definition of and I'm just going to use this, congruent segments. And we will use that a lot in this class. So I'm just giving you a preview of that is coming. It is coming, all right? So that's just kind of like a little preview to where we're going, but let's actually do what the problem's asking. So find f, g, and j, k, and then determine if they're congruent. All right, cool. So to do that, we actually have to figure out what f is and what g is. So here, f is, I'm going to use a different color. Let's use purple. F is 1, and then this is 2. So 1, 2, that's the x, that's the y. And then g is, that's 5, is the x value. Can you see it? Okay. And the y value is 1, 2, 3, 4, 5, 5. Right there. And then we're going to define these variables. I'm going to call this my x1 and this my y1, and this is going to be my x2, and this is going to be my y2 right there. So we're just going to find the distance. So okay, we're going to go over here, and I'm going to find the distance of fg, and I'm just going to write it like this, the distance of fg, and I'm going to have fg in subscript. Yeah, that's what I'm going to do. Or I guess we could just write it FG. You know, well, yeah, we'll just do this. Like that, and FG. We'll just write it like this, because we're finding the distance of FG. Okay, so we'll just write it like that, FG. FG is equal to, and we're going to write the distance formula, okay? It's the difference of the x value, so x2 minus x1 squared, plus the difference of the y values, which is y2 minus y1 squared. Okay. And then we defined our variables over here, so we're just going to substitute those values in. So we have fg is equal to the square root of, parenthesis, x2 is 5, minus x1 is 1, and all of that is squared, plus sorry about that. I just hit it. y2 is 5. Minus y1 is 2, and then we square that. All right, and then we just simplify. So, you know, you got to remember your order of operations. You got to do the parentheses first. So we're just going to simplify those parentheses. So 5 minus 1 is 4. So it's going to be 4 squared plus 5 minus 2 is 3. So 3 squared. And I'm going to keep simplifying. Got to do the exponents. Fg is equal to 4 squared is 16 plus 3 squared is 9. Okay, we're still simplifying. 16 plus 9 is 25. Ooh, I like the way this is looking. And remember, square roots cancel out squared numbers, and is 25 a squared number? Yes, it is. That is the same thing as 5 squared, and this is where I like to do my fruit ninja. The square root and the squared number, they cancel each other out. And then we are left with FG is equal to 5. So that is the distance of FG, 5. Woohoo, we figured it out. Okay, now we need to figure out what is the distance of JK. Okay. All right. So I have to be strategic about my placing here. We'll put it maybe right there. Okay. Let's get a different color that I haven't used. Green. Let's use green. Okay. Purple and green always look good together. So we're going to write JK. All right. JK. I'm going to write it right here. And then we're going to go ahead and write that distance formula again. Okay, so the distance formula is the difference of the x values squared, plus the difference of the y values squared. Okay, and you're going to write that formula in symbols every single time you use it. Write it, write it, write it. But we need to figure out what are these values. What is j? So j is, the x part is -4, and then the y part, it's right on that y-axis, so it's 0. So this is going to be our x1 and our y1. And then down here for k Okay, the x part is -1, and the y is -1, -2, -3, and that's going to be our x2, y2. So I wrote the ordered pairs, I defined my terms, I have my original formula in symbols. So yeah, now we are ready to substitute those values in for JK. So JK equals the square root. Our x2 is -1 minus our x1 is -4 squared plus our y2 is -3 minus our y1 is 0. Then we just simplify. So we have a negative and a negative. We got to do the parentheses, right? So order of operations parentheses. Negative and a negative is a positive. So we basically have -1 plus 4, which is going to be +3. So we're going to have 3 squared plus -3 minus 0, which is just 3, or it's -3, right? -3 squared. Okay. JK. Then we go 3 squared, which is 9, and then plus -3 squared, which is really -3 times -3, right? So a negative times a negative is a positive. 3 times 3 is 9, right? So we have 9 plus 9. Oh man, I keep bumping this. Equals the square root of 9 plus 9 is 18. Okay, so we're going to go ahead and put that in exact form. So we want to know about the squared numbers, right? Square roots always cancel out squared numbers. So is there a squared number that is a factor of 18? And so there is, right? JK, 18 is the same thing as 9 times 2. And I always like to write the squared number. 9 is a squared number, and I like to write that one first. So 9 times 2 is 18. 9 is a squared number. And then I'm just going to rewrite it. 9 is the same thing as 3 squared. And then we get ready for Fruit Ninja. We have the square root and square. They cancel each other out, which means we are left with 3 square roots of 2. Boom. There is our answer. Now the question is, oh, can't see. The question is, and I'm going to take all of this information and right here and kind of go up here. We want to know, is FG equal to JK? Are they equal? And I'm going to put a question mark because we're trying to figure that out. Well, what do we have? We have 5. It would be 5 equaling 3 square roots of 2, and that is not equal. So we go like that, right? That means does not equal. So that means that FJ does not equal. I guess that's the way you're supposed to do it the other way. Oh, I'm sorry. Now it looks like an X. It's not supposed to look like an X. It's supposed to look like that. So FG does not look like JK, which means that the line segment FG and the line segment JK, are they congruent? No, they are not congruent. So that just means not congruent. So line segment FG is not congruent to line segment JK. So that is our, why do I keep bumping this? I'm sorry. It keeps bumping and it keeps shaking. So I hope that you can see it. I'm trying my best to give you really, really good video quality, but I'm just messing up. So anyways, there's our answer right there. Boom shakalaka. That's what you get. So let's go ahead and try a different example. All right. So here we have another problem. It says find EF and GH and then determine if EF is congruent to GH. Okie dokers. Find EF. So let's go ahead and find EF first. To do that, I'm going to go ahead and label what these points are. E is -2, 1. And F would be -5, comma, the Y value would be 1, 2, 3, 4, 5. Okay. I'm going to call this my X1 and this my Y1. And I'm going to call this my X2 and my Y2. Okay. So now we're just going to find the distance there. So let's go over here to, and we'll write FE, or EF. Oh, we're writing it EF. Okay, EF. We'll write it EF. EF is equal to the square root, and we're going to write it in symbols first, right? So the difference of the x values, so x2 minus x1 squared plus the difference of the y values. Remember difference, that means subtraction, right? y2 minus y1 squared. Okay, okay. Then we're going to go ahead and substitute those values in. So EF equals the square root of x2 is negative 2. So negative 2 minus, what's x1? x1 is negative 5, right? Okay, yeah. And then we square that. Plus y2, oh my goodness, what did I do? This is supposed to be a y2, I'm sorry, I hope I didn't confuse anybody. Okay, x1, y1, x2, y2. Okay, y2 is right here, this is 1. 1 minus y1 is 5, and that is squared. All right, then we just do order of operations and simplify. Okay, EF is equal to, we have these two negatives. Remember, order of operations says we have to do the parentheses first. We have two negatives there, and so those are both, they turn into positives. And negative 2 plus 5 is going to be 3 squared. Plus 1 minus 5 is negative 4 squared. Okay, cool. EF equals, let me do the exponents, square root, 3 squared is the same thing as 3 times 3, which is 9, plus negative 4 squared is the same thing as negative 4 times negative 4. Negative and a negative is a positive. 4 times 4 is 16. So there we have it. 9 plus 16 means that that is the square root of 25. Oh, this makes me so happy because 25 is a squared number and square roots cancel out squared numbers. Okay, sorry. I'm in a room by myself. Weird things happen. Okay. 25 written as a squared number is the same thing as 5 squared, and the square root and the squared cancel each other out, fruit ninja, and we're left with EF is equal to 5. All right, cool. Let's go on to the next one. Make myself a little room right here. Get a different color. All right, so the first thing we have to do is go ahead and label these vertices. So G is the same thing as the X value is negative 1, and the Y value is negative 1, negative 2, negative 2. And then the H up here, the X value would be 1, 2, 3. So 3, and the Y value is just 1. Right? Right. Yeah, 1, 2, 3, 4, 5. Yep. So this is going to be, I'm going to call this my X1 and my Y1, and I'm going to call this my X2 and my Y2. Just so you know, I didn't say this before, but if this is your X2 and this is your Y2 and this is your X1 and this is your Y1, you'll get the same answer. Okay, so it doesn't matter. I'm calling this my X1, Y1, and I'm calling this my X2, Y2, but if you call this your X, if you did it vice versa, you're still going to get the same answer. Okay, the big thing is that you have to have this being X1, Y1, and this X2, Y2. You can't have you can't have this. Man, and then it shakes. Okay, you can't have this. You can't have call this X1 and then this Y2. Okay, you can't do that. So then you'll get the wrong answer. Okay, so yeah, it just needed to be said. Okay, now let's find the distance. So the distance between GH, we're going to write that distance formula. So difference of the X value is X2 minus X1, all of that squared, plus the difference of the Y value is Y2 minus Y1 squared. All right, and then we substitute the values in. So GH is equal to the square root of X2 is 3. 3 minus X1 is a negative 1, and all of that is squared, plus Y2 is 1 minus Y1 is a negative 2, and all of that is squared. All right. So we get to the order of operations. We got to do the parentheses first, okay? So we have these two negatives right there next to each other, so they end up being positive. So we have GH is equal to the square root of 3 plus 1, which is 4. So we have 4 squared. Plus, oh, we got to do the parentheses over here. We have two negatives right next to each other, so they end up being positive. 1 plus 2 is 3. 3 squared. We're going to simplify this. GH, 4 squared is the same thing as 4 times 4, which is 16. Plus 3 squared is the same thing as 3 times 3, which is 9. We have 16 plus 9, which ends up being 25, which is a squared number. So we're just going to write that. 25 is the same thing. Remember, square roots cancel out square numbers, so this is wonderful. 25 is the same thing as 5 squared. The square root and the squared cancel each other out, so it is Fruit Ninja time. They cancel out, and we're left with GH is equal to 5. Boom. So the question is, let's get purple. They want to know, determine if the line segment EF is congruent to GH, right? So let's go, is EF, is that equal to GH? That is the question. I don't know. Is it not? I don't know. Let's go ahead. So we have EF is 5 is equal to GH, which is 5, which means yes. Man, I keep bumping it. EF is equal to GH. All right, cool. So since it's equal, we can say, using the wonderful, magnificent definition of congruent segments, which is a definition that you aren't aware of yet, but we talked about it last example, so you kind of know it. We can say that. So yes, they are congruent. And that's it. That is our answer. They are congruent. Boom. All right, well, that's it for example 3. We'll see you in a little bit for example 4.